So in this video, we're going to talk about the sampling distribution for the difference in two means. And we've talked about sampling distribution so far for one proportion, two proportions, one sample mean, and now we have two sample means, all right? And so our learning intention today is to explore the sampling distribution of the difference between a two sample mean. And remember, we call the mean, there's two types of means. The population mean is called mu. That's equal to the population. And then there's the sample mean, which we call x bar. So we actually want to look at the two sample mean from the x bar, from your to look at what the statistic is doing here. And we're going to show the criteria through this so I can find the parameters of a sampling distribution. In this case, the difference in two means. Identify the mean of a sampling distribution for the difference in two means. Identify the standard deviation and calculate normal probabilities doing that. So the purpose, just like in a proportion, a two sample proportion, the purpose is still to compare. We want to compare two different distributions that have two different means. But what's really essential now is that these two different distributions are independent of each other. And they have to be independent because if they're dependent, it's going to mess up some of the calculations that we're doing here. So here is the example. In our example, it says, every day thousands of people at an airport pass through security on one of two levels, level A or level B. Suppose that on average it takes people 26 minutes to pass through security on level A with a standard deviation of 7.57. And on level B, the mean and standard deviation are 24.5 and 4 minutes respectively. So let's write out what we know. We know that on average, the level A, the security on level A, to get through that takes 26 minutes. So mu of A, the population mean, is 26, and it has a standard deviation, sigma A, which we'll say is 7.57. We know that on level B, the mean is mu of B is equal to 24.5, and it has a standard deviation of B equal to 4. It says each day the airport looks at separate random samples, which tells me that these samples are independent. Level A sample is not going to affect level B sample. So we're looking at separate random samples of 100 people. So for both these, N of A is equal to 100 and N of B is also equal to 100. They calculate the mean and they look at then they tell us they look at the difference. So we look at the difference here between the sample means. Remember what we call our sample means? We have one mean, we'll call it x bar A, minus the other mean, which we'll call x bar B. What is the probability the mean wait time for A will be less than the mean wait time for B? And remember when we set up proportions, if we're going to say that the difference in between two proportions, there's one of three things that can happen between the difference between proportions and means. The first one is that the case that they are equal. And if your difference if your difference means you're equal, if you're equal to each other, your difference when you calculate it should just be 0. So what we can say there, we can write it like this. We can say that mu of A is equal to mu of B. If we say this though, what we really can say is that when we calculate the difference, which means I'm subtracting, I'm always going to subtract from A's point of view. Mu of A minus mu of B is equal to 0. That's what equals mean when you look at the difference. If it's not equal, then it can be less than. And if we say less than, we're looking at A again. So mu of A is less than mu of B. If we say this and we look at the difference, I'm looking at the difference between A and B, this is really saying that mu of A minus mu of B. If mu of A is less than B, when you subtract it like that, you're going to get negative values less than 0. And then the last thing that it can be, if it's not less than or equal, it can be greater. And for greater we have mu of A is greater than mu of B. And if that's the case, then when we subtract the difference between those two, we're going to get mu of A minus mu of B. Your differences should be positive, greater than 0. So when we look at this problem, they want to know what is the probability the mean wait time for A will be less than the mean wait time for B. And we're looking at the sampling distribution of the sample mean. So we want to look at the sample mean. So I wrote everything in mu, but really what you're talking about are your sample mean. So we're going to use the x bars there. So we want to know what's the difference between x bar A minus x bar B. What's the chances that x bar A will be less than 0? Because we want to look at, we're saying that the wait time for A will be less than the wait time for B. So what you're really saying is that x bar A is less than x bar B. And we work it to the difference. This is what we get for our difference. We're going to look at this next, all right? And in order to do all this, then we need to go through our conditions and check things.